Hello, students. Welcome back. We are working on solving quadratic equations in this unit. We have already learned to solve them by graphing, and today we're going to start looking at an algebraic way of solving quadratics, and that would be by factoring. So it's been a little while since we have worked on factoring, so we'll do just a brief review and then apply it to equations. One thing that's different about equations is that you do have an equal sign, and before you start to work, it will be important that you get one side of the equation equal to 0 and that you write your terms in descending order. And then there are basically three types of factoring that you might have to do. One would be to take out the greatest common factor. So if you have something like x squared minus 8x, then what I'm referring to there is that we divide by x, and that means that you would take an x out and have x minus 8. So that's what I mean by factoring out the GCF. For two terms, if you have two terms and they're perfect squares, we had a formula for a squared minus b squared, and we said that that was equal to a plus b times a minus b. So we had a formula for that using the square root of the a squared and the square root of the b squared. And then for three terms, we when we were working on factoring, we did the process of splitting the middle. And that was where we made a chart and we looked at what multiplied to give us a times c and what added to give us b. So hopefully that jogs your memory a little bit. After doing the factoring, then we will use what's called the zero product property. And basically that means that you'll set each factor equal to 0 and then solve the equation that results from there. So I have four examples that we're going to use to practice solving quadratic equations by factoring. So for our first one, I have x squared minus 10x plus 25 equals 0. So remember I said that it was important that one side of the equation is equal to 0, and we have that. So now I'm looking at my terms. There is no greatest common factor that I can take out of all three terms. And since I have three terms, I'm going to identify A, B, and C. So A is 1. Remember, that's the number in front of the x squared. B is negative 10. And C is 25. I'm going to put those in a different place. So A is 1, B negative 10, C 25. All right, so we'll make a chart, and in that chart, we'll look to see what will multiply to A times C. I'm just going to abbreviate multiply right here. And so our AC in this problem is 1 times 25, or 25. And then what we'll add to give us our B value of negative 10. So when we think about all of the factors that multiply to 25, we would have 1 and 25, but that won't add to negative 10. And then we have 5 and 5. Now, 5 and 5 will add to 10. If we make both of these negative, they'll still multiply to a positive 25, and they will add to negative 10. So this is our pair that we're going to be working with. And so we will work with our equation, having x squared as our first term, and then minus 5x, minus 5x using our two negative 5's, and then plus 25 and equals 0. Now we'll kind of ignore the equal 0 for a little bit. Remember that we would draw a cut line. We could see that both these first two terms will divide by x, so we can factor out an x, leaving us with x minus 5 after we do the dividing. And then because our third term is negative, we actually will divide by a negative when we figure it out. And we can divide both of those by a 5. So we'll divide by negative 5. And when we do so, remember that you get the parentheses that matches what we got in the front side of the cut line. So we have x minus 5 inside the parentheses equals 0. And so our common factor of x minus 5, and then I'm going to mark that out. And then what was not marked out is our other factor of x minus 5. Now, here's where the new part comes in. This is equal to 0. So now we're going to set each factor equal to 0. Well, in this particular problem, both factors are x minus 5. So we can set, and I'm going to do that work right in here. So I can set x minus 5 equal to 0, add 5 to both sides of the equal sign, and I end up with x equals 5 as my answer. And I could do that for the other one, for my other factor, which was also x minus 5, but that will end up on this one giving me the exact same answer. I can add 5 to both sides of the equal sign and end up with x equals 5. So this is a quadratic that has what we call a double root. It has one answer that counts twice. And so our solution, and sometimes you will see that these are put in solution set, would be a 5. And this would be a quadratic where the graph only hits the x-axis at its vertex. All right, let's move on to question number 2. On question number 2, the equation is not already equal to 0. So we have to move the 6 to the other side. I'll do that by subtracting 6 on both sides of the equal sign. Now, as you do this, don't mistake that for being something where you add the negative 15 and the negative 6 together. They are not like terms. And so we're just going to put it in descending order, 9x squared. That's my highest exponent. And then minus 15x. And then my minus 6 will just come as the last term. And then on the right side of the equal sign, 6 minus 6 is 0. Now, I noticed that there is a greatest common factor that I could divide out, but a lot of people don't recognize that. So I'm just going to work it from here as is. So I'll identify that A is 9, that B is negative 15, and that C is negative 6. And so again, I'm going to make a chart. I want to look for what will multiply to my AC. My AC is 9 times negative 6, so negative 54. And add to B, which is negative 15. So I'm looking for factors of 54. And so I'll start with 1 and 54. and I can't make that become a 15. 2 and 27, again, that's not going to be helpful. 3 and 18. All right, now 3 and 18, if I use the right signs, I can get that to be negative 15. And so I'm going to put the negative on the 18. 3 times negative 18 will give me negative 54. 3 plus negative 18 will give me negative 15. So this is my pair that works. So going back to my problem, I'll have 9x squared, and I'll use my factors that I found. So plus 3x minus 18x, and then I'll have my minus 6. Again, I'll put the equal 0. We'll kind of ignore it for a little bit. Draw my cut line, and what will divide out of my first two terms is more than just an x. I can divide out a 3x. So that means I'll have 3x, and then inside the parentheses, after doing my dividing, so 9 divided by 3 is a 3, and then x squared divided by x is an x, plus, and then 3x divided by 3x is a 1. So again, my third term is negative, so I'm going to divide by a negative. I want to divide by the biggest number that I can. That'll go into 18 and 6, and that's going to be a 6. So negative 6 is my divisor. And when I divide, I get that 3x plus 1 inside my parentheses, just as I should have. I'm just going to bring down the equal 0. So my common factor of 3x plus 1 is going to come out, and that leaves me with 3x minus 6. And then we bring down the equal 0. All right, so here's the new part that we did like the last time, except this time we have two different parentheses. So we're going to get two different answers. So 3x plus 1 equals 0. I'll solve that one. I can subtract 1 from each side of the equal sign. That gives me 3x equals negative 1. Divide both sides by 3. Often you get a fraction. That's what we get here. We get x equals negative 1/3. Leave it as a fraction. Do not change it to a decimal. Just leave it as the fraction negative 1/3. And then I have my other parentheses, my other factor, 3x minus 6 equals 0. So notice that each parentheses I set equal to 0. I'm going to add 6 to both sides. That gives me 3x equals 6. I'll divide both sides by 3 and get my other answer, x equals 2. Now, this is two answers. They are not ordered pairs, so you can write them in any order. But if you're asked to put it in a solution set, we would have negative 1/3 and positive 2 as our two answers to this. And so this as a graph would cross the x-axis at negative 1/3 and at positive 2. All right, so if we move on to our question number 3, I'm going to clear the ink and scroll on up so I have plenty of space. So question number 3 is x squared equals 4x. Now, the temptation on a question like this is to just leave it like it is and divide both sides by an x. Doing that will eliminate one of your answers and will not give you a true picture of what your solutions are. So remember, your first step is that the equation has to equal 0. So we would want to subtract 4x from both sides of the equal sign. They're not like terms, so we just have to write them side by side. x squared minus 4x equals 0. Now I'm noticing that I only have two terms, and with this x, I do not have perfect squares. So I'm going to see if I can take out a GCF. In other words, can I divide both of these by something? And I can. I can divide them both by x. So I'll take out an x, and then that will divide out and leave. So x squared divided by x is x, and negative 4x divided by x is negative 4. I'll bring down the equal 0. Now, normally we have two parentheses. We don't have parentheses this time, but we do have two factors. The first one is this x. So I'm going to set x equal to 0, and there's nothing left to solve. That is one of my answers. And then I'll do my parentheses, x minus 4 equals 0. There is something left to do here. I can add 4 to both sides of the equal sign and get x equals 4. So this does have two answers, and they are 0 and 4. So I had a greatest common factor that I divided out so that I found my two answers. And then finally, I have problem number 4. It's already equal to 0. And this one can be handled in a couple of different ways. I could, if I recognize it, divide both of these by 4. In fact, I could divide all terms on both sides of the equal sign by 4. Some students don't recognize that. So then I might also look to see, do I have squares? And I do. 4x squared is a perfect square. I could take the square root of 4x squared and get, so if I think about what times what gives me 4, that would be 2, and then x squared would give me an x. And I can also do the square root of 36. The square root of 36 is 6. 6 times 6 gives me 36. So if you can do that to both terms, then we have the formula that you could take their square roots. So 2x plus the square root of 36, 2x plus 6, and then 2x minus 6. And those would be the factors of 4x squared minus 36. And then we'll have this equal 0. And now you've got your two parentheses. Now these will not give you the same answer. So 2x plus 6 equals 0. We will subtract 6 and get 2x equals negative 6. We can divide by 2 and get x equals negative 3. So there is one of our answers. And then we'll do the other factor, 2x minus 6 equals 0. It's similar, but it's not the same answer. So we can add 6 to both sides. We'll get 2x equals positive 6. Dividing both sides by 2, we get x equals positive 3. So we do get two answers. They are two different answers. And if you need to write your answer in a solution set, the two answers would be 3 and negative 3. So there's just a little bit about solving equations by factoring. And you saw the four techniques. So you had, the three techniques. You had splitting the middle for your first two different types of answers. One where it gave you one answer, one where it gave you two answers. Then you have for problem 3, dividing out a greatest common factor, and for problem 4, a difference of two squares. So those will be the types of factoring you'll see as you do your homework 24.